Alrighty, hi Zach, welcome to lesson number 98. This lesson is going to be awesome. Last time we learned about the Pythagorean theorem and now we're going to put it to good use when we're finding out the distance between 2 points. So that's going to be really useful. It's like a useful application of the Pythagorean theorem, just one of them. So here we go. And then afterwards, we're going to talk about the slope formula. Whoops, I messed that up. So slope formula is what we're going to do in the later part of the lesson, okay? First of all, did you know this was the most vulgar character of all time? Oh yeah, they had to beep out every single word he said. Okay, here we go. Let's jump into this. So, remember, a quick review, Pythagorean theorem. We've got a triangle like this, has to be a right triangle. The side opposite that is the hypotenuse, which is C. You've got 2 legs, which you know the lengths of, but you have an unknown hypotenuse. So to figure this out, it's going to be easy peasy. We are going to do C squared is going to be equal to 4 squared plus 7 squared. So C squared is equal to 16 plus 49. C squared is equal to 65. So C is going to be the square root of 65, and then we can just leave our answer like that, okay? And also don't forget that we've been only looking at the positive square roots, but technically it's a plus and negative sign. But if you're talking about a length, since C represents a length, we only solve for the positive square roots. But just remember that when you wrote the square root sign, not when they gave it to you, but when you wrote it, you have to consider the positive and negative square root, okay? So here's how we're going to take it to the next level. The next level is we're going to find the distance between points. So let's say that they give us these 2 points. And here's the example. Here's the example right here. It's 98.1. Find the distance between the points. Smooth. Yeah. Okay, so here's the 2 points. One of them is 4, 2. So this is going to be 4, 2. And you can see that we went over x is 4, 1. Let me get a different color so you can see it. 1, 2, 3, 4. And then y is positive 2, so we end up here. And then the other point is negative 3, negative 2. So we went negative 3, negative 2, we ended up here. So these are the 2 points. They want us to solve the distance between the 2 points. What is it? And you can see by the way I drew that line, maybe what we're going to do. So step 1 is to graph the points, which I have already done. Okay. Step 2 is to connect the points with a straight line. Draw a straight line between these points. So let me get a different color, like one that we can actually see on here. What about like a bright green? Okay, here we go. Okay, so I've connected these 2 points. And it turns out that that can be the hypotenuse of the triangle. And then you can draw the rest of the right triangle. So this side right here is going to be parallel to the y-axis. So if I just draw parallel to the y-axis and stop at the negative 2, because that's where this point is, and then the next line is going to be parallel to the x-axis, just like that. And I'm going to go all the way from this x, which is negative 3, to this x, which is positive 4. And then what I've done is I've created something that has a right angle right here. And C is the opposite side. This is C, right? But we don't have the lengths of these legs. Well, we think we don't, but do we? Turns out we do, because I just basically made this on a grid because we graphed everything. So this is 1 unit, 2 units up because of that y, and it's 2 units down because of this y. So the whole length of this is going to be 4, right? So this is going to be 4 on this side. And what about this length? Well, you're going from this positive 4 because of that x, all the way to negative 3 because of this x. A length has to be positive, so I'm just going to add like the absolute values, 4 plus 3, and that means that this length is going to be 7. Okay, so I'm just going to write a 7 there. And we're solving for c, right? So that's basically how we do these problems when they ask us to find the distance between 2 points. So now it's going to be c squared equals 7 squared plus 4 squared. And now you solve it just like anything else. C squared is equal to 65. And then c is going to be, well, I'll just write it underneath. C is equal to the square root of 65. And you can just leave it like that. Cool. All right, now let's do 98.2. This guy's, he's saying, sometimes my genius. It's almost frightening. You can say it with an English accent probably. Okay, 98.2. Let's do this example. It says find the distance between the points 3, negative 4 and negative 5, 2. So step 1, let's plot those. We're going to start with 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. It's going to be way down here that I put my dot, okay? And the next one is negative 5, 2, so we're going to go 1, 2, 3, 4, 5, and a positive 2, so my next dot is going to be right here. Okay, step 2, draw a line between those dots. Okay, step 3 is to make a right triangle. Now, it doesn't really matter. I could do it this way, or I could do it this way. And turns out it doesn't matter which way I do it. You'll get the right answer either way. So I'll do it the same way as the book and just make a right triangle like this. Perfect. This one needs to come in just a little bit, but that's okay. Alrighty, and then this is my right angle, of course. So that means this distance is C because this is the hypotenuse. Okay. And then they named it D, so why don't I do that just to make it less confusing. They put a D just for distance. And then we have to figure out what is this length and what is this length. And we can do that because we're basically taking the 3 here, 1, 2, 3 units, and then 4, 5, 6, 7, 8. So you've got the 3 and the negative 5. And if you just add the absolute values of those, then you can see this is going to be a distance of 8. Okay, what about this up and down distance? You've got a negative 4 going all the way up to a positive 2. So it's going to be 4 plus 2, so this is 6. So then the way we figure it out is going to be d squared is equal to 8 squared plus 6 squared. Okay, we can do that. So d squared is equal to 64 plus 36. 64 and 36 turns out to be 100. Take the square root of each, and then d is equal to 10. And it's actually plus or minus 10, but we're only going to use the positive one because it's a distance. So sweet. Alrighty, we did it. Now let's move on to the next part of the lesson, which is the slope formula. This is going to be really cool. You're going to be looking like this. You're going to be like, whoa, I can't believe you just did that. Yeah, this is how you remember. If you've got a line like this, as shown in this picture here, that the slope of a line, or m, like remember that equation, y equals mx plus b? M represents the slope of the line. And how do you define the slope of the line? It's the change in y over change in x. Or you could think about it as rise over run. How much does it rise? How much does it run? Rise over run. Okay, so here we go. We're going to find the slope of the line that goes through these points, 4, 3, and negative 2, 2. So we've got 4, 3, and we've got -2, comma, -2. So that's this point, and that's this point, okay? First, we graph the points, and then we draw a line, okay? So they already did that for us in the picture. We graphed the points. There's the line, okay? Now, the sign of the slope. So what is the sign of x? You can have an m. You can have a positive m, which means it's sloping upward like that, or you can have a negative m, which means you're going downhill like that. So the slope can be positive or negative, so don't forget about that. The slope of this line is going to be positive because of the way it's graphed. It looks like that, okay? So it slants towards the upper right, so it's got to be a positive slope. So on the right, we're in the other picture that it has there. Let's see if I brought the other picture. Yes. So this is the picture to the right. Now we draw a triangle, which they've done here. Whoops. It's a right triangle. And this line that we drew before, that is the hypotenuse of the triangle. And we're trying to figure out the slope. Okay? All right. Now, from this triangle, you can see that what is the difference in the x coordinates? So what is change in x? So this is, remember the slope formula? Okay, let me actually write it down. Slope is change in y over change in x. Okay, so let's start with the change in y, I guess. So the change in y, this is the y-axis. So how much does it change up and down? So the change in y is, if we zoom in and count the units, 1, 2, 3, 4, 5, and they put a 5 there. So it's one of the legs of the triangle. 5. And then what's the change in x? That's this one. You can count the units. You can see that they drew a 6 there. So the slope is 5 over 6. And then what is the sign of the slope? It's positive because this is sloping upward. Okay, so the slope we just figured out is 5 over 6. And it's just the ratio of rise over run, or the change in y over the change in x. All right, now, turns out you don't even need to graph the points to find the slope. Now, you're even more excited than you were before because, you know, who likes graphing? But you don't have to actually graph it because you know that it's the slope is, let me get a different color that you can actually see on that. The slope is change in y over change in x. So if they give you x and y, which they do when they give you the points, then all you have to do is the rise is going to be y2 minus y1. The run, rise over run, is going to be x2 minus x1. Okay? So don't get that confused because the y is going to go on top here of your slope. The x, the difference in x is going to go on the bottom part of your slope formula. But we can figure it out without graphing it. And here's the mathematical part that you should remember. So slope of a line through 2 points. If you're asked to find the slope of the line between 2 points, the given points, point 1 is x1, y1. Point 2 is x2, y2. And then the line that passes through points 1 and 2 has this slope. M equals y2 minus y1 over x2 minus x1. You could also write that as change in y over change in x, or you could also say rise over run. Rise is how much it goes up and down, like the sun rises and sets. Run is how much you run horizontally over that distance. Okay, and also another important thing. which point is considered to be P1 and which point is considered to be P2, it doesn't matter. So if they give you 2 points and you're like, well, which one's P1 and which one's P2, as long as you keep the X1 with the Y1, and as long as you keep the X2 with the Y2, then you'll get the right answer. But don't start mixing them up. You know, keep the same. If you've got X1 here, you have to have the Y1 here. And if you start with X2, you have to start with Y2. Okay, let's do example 98.3. Find the slope of the line that passes through the points -3, 4, and 5, -2. Now, you could graph it. If you're not sure and you want to graph it, then you can always do that. But we know the formula, so we can just use the formula. And the formula is, the slope is y2 minus y1 over x2 minus x1. Okay, sweet. So let's just say that this is 0.1, and let's just say that this is P2. And the only reason I do that is because you don't want to mix them up with each other. So if we start with y2 minus y1, then we have to pick y2 from here. So it's going to be -2, and we subtract from it y1, which is 4. -2 minus 4. I can already see what the problems are going to be like, because if there's a negative here, just think you're going to have to do y2 minus a negative number, which ends up being a positive, right? 2 negatives make a positive. All right, let's go to this x2 minus x1. I want you to start thinking like that, right? So how could they mess you up on this? What is the test question going to be when you start reading these lessons? Because that's the key to doing well on tests, is you can anticipate which questions they're going to ask. All right, the bottom part is going to be x2 minus x1. So x2 is going to be here, 5 minus, and then this is x1 minus a -3. So when we simplify this, we get on the top -2 minus 4, which is -6, and on the bottom we have 5 minus a -3, which is 5 plus 3, which is 8. Okay, so we have -6 over 8, which is equal to you can simplify that to -3 over 4. So the slope is going to be -3 over 4. And that's the answer. Sweet, huh? Not too bad, right? Yay! I know you're thrilled about this. You're just having so much fun. All right, let's do 98.4. We're going to do 98.3 again. 98.4 says, do the same problem again, but this time use this one as 0.1 and this one as 0.2. So that's the opposite of what we did before. So now this is going to be P1, and this is going to be P2. Okay, so think in your head, what's going to happen? Is your slope going to be the same, or is your slope going to be different? Does it matter which one you pick? And the theorem told us that it doesn't matter. So we should get the same thing. We should get the same slope. But let's see if we do. So let's write the formula first. Your teacher next year is going to love you for writing the formula first. Change in y over change in x, right? Or you can say y2 minus y1 over x2 minus x1. All right? So m is equal to, I'm going to start plugging into this equation. On the top, we have y2 minus y1. So now this one is going to be y2, because that's P.2, 4 minus y1, which is a -2. 4 minus -2. And then on the bottom, we have x2 minus x1. This is the second point, so it's going to be x2 right here, -3, minus x1, which is 5. Okay, now let's do the math. 4 minus a -2 is 4 plus 2, which is 6. And -3 minus 5 is -8. And if we simplify this, we get -3/4. Wow, bada bing, bada boom. Look at that. Same answer as before. We did it both ways, and we basically proved that the answer is going to be the same. So it doesn't matter which point you pick as point 1 or point 2. The same slope is found by using the slope formula. It's basically, when you think about what you're doing, like why doesn't it matter that you use the same points or different points? It's like if you have 2 different points here and you draw your hypotenuse, it doesn't matter which one you use because you're either drawing a triangle this way to solve it. Whoops, it's supposed to be a triangle. You're either drawing a triangle this way and you're still using C as the hypotenuse, or you're drawing a triangle this way and you're using, that's what you're doing. It doesn't matter. So if you do x2 minus x1 or x1 minus x2, it doesn't matter because you're basically still finding the hypotenuse no matter which right triangle you draw. Isn't that cool? All right, so cool. I love it. So when we get this sorted out, there'll be Nobel Prizes in it for us. Probably, right? Yeah, maybe you deserve one after you do all this math. This is a lot of math. All right, have fun with it. Love ya. Bye.